careful measuring in lab. As they're measuring things, they realize that they need some kind of standards for atomic mass. They know that such thing as oxygen exists. They have isolated carbon from lamp black. People imagine those chemists we talked about sitting in basements burning candles up against pieces of metal until you get a deposit of what on them? Carbon, pure carbon, lamp black. Isolating that, working with it. By 1860, we have set standards for atomic mass. There are defined standards for atomic mass. And Mendeleev comes along in 1869 in a manner not so much different than what you did with these little note cards with the names of foods on them. He tries to arrange all the data that we have about all the elements we know about. And he literally has them written on the note cards, on pieces of paper. And he sits at his table and shuffles them and sorts them and tries to group them in ways that make sense. It's like playing solitaire with each element. Pretty much what you guys did, trying to group things in a way that makes sense. So, what he observes is that when you line them up based on atomic mass, suddenly starts to see patterns. So, he arranges it based on atomic mass. And he leaves gaps because there are masses that, there are no elements known that fit those masses. And his hunch is that there are elements that we don't yet know about. Of course, he was right. That's what we do in science. So he leaves gaps for elements that are yet to be discovered. So Moseley comes along a little bit later. By this point, we also know about nuclear charge, which is actually just over protons. Moseley rearranges the periodic table in order of increasing number of protons, increasing nuclear charge. So look at your periodic table. How is it arranged today? In order of mass or in order of increasing number of protons? Increasing number of protons. That's still the configuration we use today. Now there are still a couple differences between Moseley's periodic table and the one you have in your hands, but the basic bones of the periodic table by that point are in place. So when you look at the periodic table that Moseley, Mendeleev, and put together and Moseley modified, what becomes apparent is this thing called periodic law. That physical and chemical properties of elements are periodic functions of their atomic number. What does it mean if something is periodic? Happens periodically, every now and again. I can't remember if I said, well, it means it happens randomly or rarely. Yes, there is a specific period of recurrence. So the sun comes up periodically. Every 24 hours, the sun comes up. Every autumn, the leaves fall off the trees. There's a regular period of recurrence. And so there's a cyclical aspect to periodic functions. Okay. Moseley's table plus one thing is the modern periodic table. And what happens, you all know this, when you line it up this way, if we go down a group, which are the columns, those things tend to have similar characteristics. You know that, you've known that from physical science, you probably knew that in 7th grade. That's not news to you. Okay, here's one of the things that was an addition from Moseley's periodic table. They didn't know about noble gases, so let's think about that. How do you discover an element? I don't know, you look under rocks, you look in your closet, you empty that shoebox, it's under your desk. You look for things reacting with other things, right? That's how you discover elements. You run reactions and you analyze the resulting substances. But what do you know about noble gases? They don't react. So we were a little slow on the uptake in figuring those out. Because by their very nature, they're kind of hiding in plain sight. Argon was discovered in the late 1800s, 1894. We knew about helium. Now, I'm not counting on how we knew, but we knew. Helium is being manufactured in the sun. Smash two what together and you get a helium. Smash two hydrogens together, you produce helium. So at this point, we've got helium and we've got argon, and they behave in similar ways. It's proposed that there should be a group point. So we need some, they don't behave like anything else. They are their own things, even their own group. Well then, 1898, Ramsey finds krypton and xenon. They also fit this profile. They fit this profile of being non-reactive, and in 1900, radon is discovered. They also fit the profile. A new group is created, and that is group 18. So prior to that time, periodic table only had 17 groups. It went over to fluorine and chlorine and stopped. That additional group is added later.
Where did helium argon?
Everywhere. I mean, that's a good question. Where were helium and argon before? There is argon in the air. When you take in a lung full of air, you're taking in some argon atoms.
Where did they put it on the periodic table?
The new group was created to accommodate them. Because prior to that, they were sort of like off to the side. You know, like, yeah. And in order of increasing atomic mass, you know, helium would have been after hydrogen, but it's unclear whether it goes here or goes here. You know, does it go above beryllium? Does it go above fluorine? Yes, sir. We're going to talk about that in a second. Hydrogen is on there twice, and we are going to cross one of those out in a little while. There's a good reason for that. So yeah, once you add that group 18, you now have the complete modern periodic table. Okay, these two funny rows at the bottom, have you ever wondered about them? No? Okay. Some of you haven't, some of you have. It's okay. There's a Lanthanides Actinides series, and they're big, they're bad, they're highly reactive and mostly radioactive. Woo! Yeah. Huh? Yeah. Big, bad, and radioactive. They are stuck down here as a space saver. I have spent years trying to find a periodic table that incorporates them into the body of the periodic table and can be printed on this sheet and is readable. No luck yet. We're going to see how the periodic table should look. As I'll tell you, the periodic table you've all grown up with, that you know and that you love, that you go home and look at every night before bedtime, will make much more sense to you once you see the Lanthanides and Actinides where they're supposed to be. It really will. It's like little light bulbs go on. It's like a Christmas tree right now. Okay, periodicity. We already said this. It's the tendency to recur at a regular interval. So the sun rises periodically. The bell here rings periodically.